signal carrying specific chemical messengers travels down the axon and it arrives at the end of the neuron, called the axon terminal. Once the signal reaches the axon terminal, it'll stimulate certain channels on the outer edge of the axon terminal to open. This allows the flow of channel-specific ions into the axon terminal, which will depolarize the cell. The signal moves towards the outer edge of the axon terminal because of the influx of the channel-specific ion. The vesicle containing the chemical messenger binds to the outer membrane of the axon terminal. The vesicle dumps the chemical messenger into the space between the axon terminal of one neuron, the sending neuron, and the dendrite of another neuron, the receiving neuron. Those chemical messengers will bind to a site on the receiving neuron, and the site of the receiving neuron will then change shape, which will allow the channel to open, and ions will flow into the receiving neuron. If there's an influx of positively charged ions, it's called an excitatory postsynaptic potential, causing the cell to become more positive. If there's a net influx of negatively charged ions, it's called an inhibitory postsynaptic potential, causing the cell to become more negative.